Hey, Rani here. Shall we make a game? And today we are going to start getting things to interact with this nav mesh that we got importing last time. So the first thing I need to do realistically is be able to take a point in 3D space and find the most kind of eligible nav mesh tile for it. So to do that, I need to be able to constrain a point to a nav mesh tile. So the way it's basically going to work is that if I've say got a point here in 3D space, it needs to be able to go like, well, nearest nav mesh tile is this, or if it's directly over one, it needs to just go what's there, and then give me the coordinate. Yeah, that's pretty much it. That's pretty much all there is to it. So to do that, I'm going to need to get the distance to the edges. So I've got these normals pointing away, so I need to be able to do the dot product between that and the distance between the point 3D space and one of the vertices of that edge and the normal, which will give us the distance over that edge. We can then find the triangle with the smallest distance. The other thing we're going to have to take into account is if we're kind of over, ideally it would find a triangle that we're over, so it doesn't like having to transport. If I say up here and there's a platform down here, it'll pick this triangle and not the one down there. But also if we're like more than say a centimeter below this one, pick that one. We need a bit of tolerance, because this floating point is not perfectly accurate. So I'm going to do something horrifying. I am going to write some math code. I think I'll make it a separate header for it because, other than the math one, because I don't know really. Maybe I just have a whole thing for vector operations. Yeah, let's do that. So, he's writing a vector math library, boys. Get them. Now today, we're probably going to have a slightly shorter than normal stream for a Saturday. I'd normally try and push for 2 hours on the weekend, but just because of the things going on, I can't quite do that. So, yeah, let's add a dot product function, and it's going to take an immutable input. Let's call it dot product. Yeah, there we go. We like being wordy around here if you hadn't noticed already. And yeah, so it's going to take arbitrary length vectors. Oh wait, these need to be pointers, don't they? Yep, they do. So what you guys want to check is C const pointer, because you can put const here or you can put it here, and I'm not entirely sure what the difference is. Let's have a look. Okay, so if you put the start after the type, after the kind of base type, it's a pointer to a character where you can't change the value of the character. But I'm going to guess you can still change the pointer. If we put it there, so at the very end. Okay, so I probably actually want that one. Man, that is confusing as heck. That's basically I'm sure there is logic to that, but that just doesn't make any sense to me at all. So can I do that? Okay, I put the asterisk in the wrong place. There we go. So that is a pointer we can't change to memory we can't change. Fair enough. Very good. All right then. So next up, I'm just going to document this. Calculates the dot. That should be our wasm type. Product of two vectors. First vector to. What's the verb for like a dot product? Because I guess being a product, it's a multiply. Yeah, I'm gonna go with that. Might be wrong, but it makes sense to me. I have an English justification for it, I guess. And then we're going to return the dot product of produce. Oh no, this is the day where I can't type, isn't it? Oh well. And I'm just going to implement this nice and quickly. This is going to be dead simple to implement. There's two ways of implementing this actually. So I could loop over, yeah, from 0 to. So what I'm currently working on is I have this nav mesh structure, and I'm basically trying to make objects kind of interact with it. So we're starting off by, given the point in space, where's the nearest tile? So I need some basic maths libraries to do that. I'm going to go for the dumbest implementation of this I can, which is, let's go grab this index type I have. And I'm just going to iterate from like 0 to wherever, I guess. Fast. I don't know if I'm fast. So basically just going to loop over the two arrays, multiply the items in each array together, and then return and sum them to return that. Okay, that might work. Who knows? We won't know for a while. So where's my... Here it is. I really need to make like a separate sort of folder for the... Have I not committed that? I thought I did. Oh, okay. So next up, I need a function to... here it is. Given a navigation mesh and a point... No, I don't think I have. I mostly don't... I've mostly not really touched the Python world, which I know is kind of... Yeah. It's like in classic rock and never having listened to AC/DC, I guess. But does it basically kind of give you the ability to sort of because OpenAI we're talking ChatGPT and stuff, right? Does it give you the ability to kind of say send prompts and get the responses and things like that? Because I've seen the thing where someone took a picture of a whiteboard and it wrote the code for it, which was insane, and I can't believe that's real. Yeah, I'd be kind of curious to see what you could do with it, because like it definitely looks pretty powerful. But again, it's a space I haven't really looked into that much. Something I was actually considering for kind of like long term, not for this project, but for other stuff you could do with this is I've got this like really crude kind of like software renderer, and it's good enough that you can get recognizable objects in it, but like it's probably never going to go beyond that. And I was kind of curious to know if I could actually do some paint overs of a few scenes and maybe get machine learning to kind of turn really fast to produce pixel graphics into something a bit more interesting, a bit different. Okay, so find the closest point and navigation mesh to a point in 3D space. So I need to return both the point and the distance. Don't worry. I mean, I watched the odd VOD back just to kind of like sort of like self-evaluate, and I'm like, man, I can't even follow what I'm doing here, and I'm like, I'm the person who was speaking this gibberish. Okay. So we need to give this the location that we're sampling from. And we're going to need the ability to, hang on, gone blank. Ah! So yeah, so we're giving it a point and a navigation mesh, and then we are we're calculating the closest point on the nav mesh. We're calculating, well, we're going to also return which triangle it was actually on, because that's going to be really important if you're kind of like, say, using that for collision or something. Now, one thing is that we want to definitely prioritize, say, like if we have two nav meshes, right, and we're trying to figure out which one the character is closest to, ideally it would always be going down. You know, if there were two and it was actually technically closest to this one, but it would involve going up, we actually want to prefer the one that's down. That actually gets quite complicated, because you could end up with things like, say, this, you know, so having kind of like a branch going around here and a branch going around there. Pretty much, yeah, but like not even I can remember what these functions do half the time, so it helps a bit. Yeah, so you might have, like, say, like, actually, let me get an sprite open and kind of draw what I'm talking about, rather than just... So yeah, so you might have, say, a nav mesh that kind of does this, right? And you got a staircase here, so you got like two levels on it. And then you might have another one here like this. Right, so if the point was here that we're sampling, we wouldn't want to put the player on this because they're below it. We'd want it to go down and kind of like, you know, select whatever's there. But if the player was here, we would still want to do that. You know, again, like, we wouldn't want to go into this because the player should be falling onto an object. However, if the player was like here, we would have to take this kind of like our worst, you know, our kind of like last resort, because we've got to put the player somewhere, and we need to go up if there's no other choice. And while we can kind of compute that within, you know, within a single nav mesh, no problem. However, if we're calling this function one nav mesh at a time, we're going to have a bit of a problem in that we don't know, you know, we might be like going, well, you know, as last resort, go up, but we don't know if there's another nav mesh in this function that might be a better candidate. So I might actually need two separate functions, one of which is kind of like, you know, best effort, but it might not find something, and one of which is last resort, take anything you can. Maybe this doesn't actually belong in here. Maybe this actually belongs in the thing that lists them. I think it might do. Yeah, I'm gonna do that. And probably gonna make it just crash or something if there's no navigation meshes at all. So, you know, if we're like going, well, you know, find me the nearest triangle to this, and it's just kind of like, well, there aren't any. Well, I don't really know what's meant to do at that point. And what we're going to call this? I guess closest. That'll do. Doesn't take an image, just take an image. Okay, so we want a constant. I'm just going to look this up again. What was the wording on this? Const. So const the type asterisk const. Okay. Hang on, so we want a constant pointer. Yeah, so that goes there. Man, that is such a confusing part to see. So yeah, like, you got a pointer, right? What that actually is basically the location of something in memory. Now, in C, you can say that something is, you can say that something is const, so you can't change it. So for example, you know, if I'm if I'm giving you a number that I want you to calculate something from, but I don't want you to be able to change it, you can declare it to be const. But where that gets confusing is where you've got pointers, because I'm going like, right, here's a location in memory, and there's actually two different ways that can be constant. It can either be, here's a location in memory and you can't change the location, or here's a location to memory, you can't change what it points to. But you can also do both. You can go, here's a location in memory that you can't change, and you also can't change what it points to. And I can never remember which way around they are. Oh, I should probably also output the... Don't worry about it. I mean, like, I'll be honest, I don't actually know anything about C++, really. I know that it kind of evolved from C. They added like classes and God knows what else. I was actually surprised to find out it doesn't have a garbage collector, does it? Which is kind of weird for a... Does C++ have a garbage collector? Okay, native C++ by default has no such thing. Yeah, because I got confused about this before. Like I said to someone in the conversation, well, you know, garbage collector languages like C++, and we're like, what? Because the... yeah, pretty much, yeah. Yeah, so like some implementations have it and some don't. So that's lovely and confusing. Like such a fundamental thing like memory management isn't even consistent in C++. Yeah, so we also have to get the component ID out. Okay, so this actually needs to be a... Hang on, I'm having a brain implosion. So one of the things that is kind of cursed about this code base is I don't have a memory allocator. There's no garbage collector, and I can't even do like classic allocation. So everything's just in like global arrays because to hell with it, who cares? Okay, so we're going to output the and I found out the other day about 4-level paging. That was quite a revelation. That's a where can I find a good image of this? Yeah, so it turns out that the pointer isn't actually just an address. It's actually hang on. So some of it is kind of an address, but most of it is kind of just like indexes into 4 nested tables, which is... It actually makes sense when you think about like, you know, trying to avoid having to have like absolutely gigantic tables, you know, splitting up into multiple layers, but damn, this is complex and confusing. I'm glad I don't have to think about this on the daily. So we've got a closest triangle. And we've got the closest component ID. Let's just get the component ID out there as well. Okay. Now we've got to iterate over the yeah, we've got to iterate over the matrices, and yeah. So smart pointers, what are they all about? Let's have a look. Is that like a pointer that the garbage collector knows about? So, oh, what have I worked with? a long time ago, I learned BASIC. That was a terrible mistake. Don't learn BASIC. Since then, it's been C, C Sharp, JavaScript, and TypeScript, which is sort of its own language, kinda. It's basically just like stuff on top of JavaScript. Did I say PHP already? PHP, unfortunately. Yeah. Oh, GLSL. GLSL is another one that I've kind of played around with a lot. Do I have an Infinity? No, I don't. That'll do. And any point that we find should be closer than positive infinity. Okay, so now we need to transform the point that we have into the local space of the navigation mesh. So yeah, so if this has, say, been moved from here to here and the point is here, we need to kind of reverse that transform. So we're going to my matrix thing. I've got matrix multiply here, that's for combining matrices. View matrix, matrix image. Oh, okay. I might not have one to Now I actually kind of need to do an inverse multiply. Trying to remember how that works. It's been a while. I need to take a point in 3D space and do the opposite of a matrix multiply to it. I don't think that's as simple as yeah, it's not as simple as doing the transpose of the 3x3 part and then negating the other half. I know I've got code to do this somewhere, but I can't remember where. Okay, so for now, I'm going to pretend the matrix never has. I'm going to pretend that there's never a transform. So we're going to then get the navigation mesh out. Oh, hang on, that needs to be a pointer to it. So we've got a navigation mesh here, and then we can go through all the triangles, and then we can kind of like do our maths there. Should probably name this something other than just index so I can tell which index I'm talking about, because I'm about to have a triangle index, triangle index within a navigation mesh. Okay, so next thing we need to do is we need to take the, just thinking about this, we need to get the coordinates of the triangle. Just occurs to me as a better way of doing this. It's basically what we did in here where I'm, yeah, using this kind of pointer. Let's do that. Let's pointer-based approach. Oh, that said, I'm going to need the index though. So yeah, let's just pretend we didn't see that. Okay, so we've got the triangle. Next thing we need to do is we need to constrain the point that we've just that we've got up here to the triangle. So we can get the distance on the kind of z-axis pretty easily. Okay, so what's it saying here? What's it saying? We need to get the pointers to it. Okay. You go tell me what's in that seat, Visual Studio Code, or we're just gonna sit here and just stare at each other? What's this talking about? What's it? Oh, it needs to be const. Okay, there we go. Yeah? Yeah, are we happy with that now, Visual Studio Code? There we go, there we go. Okay, so let's go back to this vector kind of thing and let's add a subtract in here. Right, I just need to consult my list here. Which way? So I want a pointer that I can't change. That's the one. Yeah. Hang on. Ah, my brain's melting. So I want a pointer where I can change the character, but I can't make the point to a different one. That's what we want. Man, it's such a weird and confusing bit of syntax, that. So I'm going to write pretty much the same thing, except it's just that. Nice and simple. I need to import the header for that function I've just written, which is vector, I think. Yep, okay, so now we can, hang on, we take the point in 3D space that we're sampling, and we take the point on the triangle, the kind of corner of the triangle, and then we store that in our, we store that in our kind of array. And then next thing we need to do is we need to perform the dot product of that with the normal. Okay, right, so okay, so now we have the if I just draw this out, I might pick a slightly thicker line, I think. Let's go for, say, like that. So I've got my triangle and I've got like point A, I've got point B, and I've got point C. What we've done here is basically got like the, we have a normal pointing this way, right? A unit vector pointing that way. And we have our point in 3D space. Basically getting the difference between that and that. And then we are calculating the dot product between that and that, which should give us the distance over that line in that direction. So we will then be able to push this point back over this line by just subtracting this normal multiplied by the dot product. But we're going to have to consider all three sides, because it's possible that it's, say, over both this side and this side, in which case we need to calculate the distance to sort of here. Now, C doesn't have overloading. I'm about to do something that might warrant a bit of overloading. I wrote the wrong 2. What am I doing? Right, this isn't going to be a pointer anymore, so we can get rid of that. And let's just do a quick implementation on this. It shouldn't take super long. Again, it's going to be very, very similar to this. Dead easy, dead easy, dead easy. Oops. Okay, so yeah, sorry, just having a real good think there. So yeah, so we're getting the difference between our point and the point on the triangle. We're then doing the dot product with the normal along the edge, which means we're getting how far over the edge we are. Then we're multiplying that distance by the, wait, we need to be multiplying by the edge normal. Where is it? Yeah, let's just capture this in a variable so we're not constantly here replacing it. And then we're multiplying that by that. I've renamed these, so that should at that point. Wait, I forgot to tell it how many sides, how many axes are on that. Okay, so at that point, Okay, so that's now applied the first wall to it. Basically just need to replicate this like a bunch more times. And we should end up with a nice working implement. We should end up with it nicely constrained. Thinking about it, I could, in theory, actually make this a loop. I probably should make this a loop, to be perfectly honest. Okay, so yeah, so our point should now be kind of like constrained from the triangle. And another thing I should probably do is record in here whether we've managed to get a point that's, you know, whether we've actually managed to be above a triangle yet. Yeah, one of the things about C, right? It's such a simple language. It literally doesn't have a Boolean type by default. You have to import a header for that, which is it's still so funny to me. So this is where I'm going to kind of like this is where the reason why I didn't just make this a loop will become a bit more apparent. I'm actually going to break into here, and I'm going to use the surface normal to calculate the distance between the triangle and the, you know, if you take the triangle and you basically delete the edges, how far away is it in 3D space? You know, if it was able to just go straight down to the surface, no matter where it was, how far would that be? I think is it just called normal? Oh, that's so bad. I should have called it surface normal. Anyway. I might rename that. I'm going to rename that just because it's going to be confusing. There's so many normals in here. I mean, I even called it surface normal in the comment. What was I thinking? I don't think it's going to be used anywhere else. That should be fine. So now we can... And one of the nice things about this is actually a sine distance. So if we're above the surface, we'll actually get a positive distance. If we're below it, we'll get a negative distance. So, you know, we can use that, we can take that into account here, and we can actually sort of like early exit this loop if it turns out we're below the triangle and we've already found one triangle that's above. Okay, so distance to surface, and we're going to do our dot product again. And we're actually going to reuse that calculation we did earlier to find the distance between the first point on the triangle and the point that we're kind of calculating. I'm going to reuse that. And just thought of something, I could actually reuse this down here. Hang on, no, it's this one I can reuse. Because what I can actually do here, it's a bit cheeky, is at the moment, if I just get rid of all these lines, what I'm doing is I forgot to take a point here. I'm taking the distance from here, and distance from here. But as long as the point I'm sampling from is on the same line, it doesn't really matter whether it's a vertex already previously used. So I can actually just take the difference, the distance from two of these vertices, and it'll eliminate a whole bunch of math we otherwise don't need to do. Anyway, so we've now got the distance to the surface. If the distance to the surface is, I'm going to give this a kind of like a, bit of tolerance. So you can be slightly below the surface, it'll still count as on top of it. It's purely so that rounding error doesn't mean you fall through things. So if we are below the surface and the closest point is above the triangle, then skip this triangle. We don't care. It's worse than whatever we've previously got. Let's store this in a variable because we're going to be storing it. Yeah, I really shouldn't have reused this, should I? What's the difference used in here? How often do I write to it? So multiply. Yeah, let's make a new variable for that just so I'm not overwriting it. I think that'd be a good idea because then I can reuse it between edges. So yeah, what's going on here is because I've got like I've got a point in 3D space, and I basically need to check the distance between this line and this point, and this line and this point. In both cases, I can actually sample from the same vertex, so I can actually save myself a lookup and some additional subtraction. Probably introduce a bunch of bugs in the process. That's always how it works, but okay, we no longer need to do that subtraction, we already have it. We already have it here as well. Yeah, and then we only need to do one more subtraction down here, so that's good, that's good. We've eliminated a bunch of operations. So now, I'm actually going to make this be the square of the distance to the closest point, because it means we can skip the square root until the end. And I've just realized I might not be able to do a square root because I don't actually have the math library. However, I don't need it. I don't actually need the exact, I don't actually need the real distance. That's fine for us. We can just use the square. Okay, so just thinking about, is there a really good way I can kind of do this without trying to avoid like doing tons of math I don't need to. So basically what I now have is I now have the point in 3D space kind of constrained within the three walls of the triangle, and now I need to constrain it to the surface. Thinking about it, I probably could have done that up here. I'm going to do that up here. So I'm going to okay, so that should place the point on the triangle and constrain it to the edges. So next up, we can calculate the distance between the points that we've actually, ended up constraining and the point that we fed in. So I'm going to add a new kind of helper in here for that. It should be dead easy. So this is as simple as oh, it's actually just the dot product, isn't it, between the two inputs? Yeah, I'll just make it do that. No, it's the dot product between the difference between the two inputs. Yeah, nearly trapped my, nearly did something stupid there. Okay, so now we've got our constraint point, we've got a point, we've got a distance function, and now we have the distance squared. So if we if we now have a point above the triangle and we previously had a point that was below the triangle, then we take priority. Otherwise, if we're closer, then we take priority. Okay, so now we've calculated that, and the next thing I think we need to do is actually store the exact yeah, we need to save to these, don't we? Yeah. Let's add a kind of like a copy helper in here. It's basically going to be memset, although we don't have memset, so yeah, that should work. Incidentally, writing your own vector math library, usually not a good idea. Can't really explain why I'm doing it. Okay, so we need to copy. Yep, that's good. And then we need to assign the closest component ID. I'm just going to fetch it here, as it's not going to be that. It's possible that we might say, you know, take 5 or more triangles before we find the best one, but there shouldn't be that many navigation meshes on the screen that doing a lookup that we never use is going to be a problem. Oops. Oh, I don't actually keep a reference back to the component ID from here. You have to put one in. Damn, nearly an hour. Damn, where's that gone? And then we just need to keep a reference to this as well. So again, we're going to assign that to, yeah, the kind of way you do out parameters in C is that you literally just give a parameter, so a pointer to some memory and just overwrite it. It's basically all of what C is, right? Okay, that might work. So to visualize this, I'm going to go back to my kind of advanced function. Let's just build this and make sure it builds. Oh, I've changed the header file, haven't I? Oh, it didn't like that. Okay, we have some kind of error. Oh, it didn't like that. Oh yeah, that needs to go after the pointer. So even when I've looked it up, I'm still making mistakes with this bloody syntax. It's just far too complicated. And then, oh yeah, we're not actually, I still got the parameter to actually pass in a specific navigation mesh. We're not using that because we're scanning all of them. Okay, that's building, that's good. So the next thing is I've got this advanced function in, oh, nope, it's not quite built yet. So the next thing is I don't really have any kind of random generation in this. So like I was hoping to just sample a bunch of points and then, you know, like draw lines from them. I don't currently have any kind of random generation. That should be void. Shouldn't return anything. Maybe should that. Yeah, only the things that kind of like collapse down to a single value like dot products are going to return. Man, I'm giving the compiler such a hard time with this project. Okay, so it still builds, but currently doesn't look any different. So next up, we need to actually start picking sort of points in 3D space around this. Where's the advanced? Here it is. This is basically the code that runs every frame. So let's do something quick and dirty here. Let's how are we going to do this? Does C have does it do float modulo? It's not built in. Well, that's great. Okay. Yeah, it's there's no operator for it to function, which we're not going to have because we don't have a math library. Okay, I've got an idea. What we can do is we can use our trigonometry functions. To give it kind of like a, this will be not quite random, but like sort of complex enough sort of motion that we'll be seeing plenty of edge cases as they arise. So now we should be able to go into the, yeah, get that. And we don't care about the, hang on, we don't care about these two parameters, so I'm just going to have to add a local variable for it and then not use it. That's fine. And then we need to give those as pointers. So we're basically telling this function, you know, here's somewhere where you can put information. Here's the memory address. We want you to dump the result in. Okay, let's go. What does this do? It doesn't crash. Okay, that's good. That's good. Next up, let's draw some lines. Oh, we also need to transform this into view space. Oh, this is turning into a right little nightmare, isn't it? Yeah, I was really kind of hoping to get some kind of a start on sort of like the ray casting I was going to do, and like sliding collision with the nav mesh, or maybe even start building some components. But I guess this has been a good enough run for today. Okay. Model view projection matrix. Oh, this is already in world space, so we just want to get the stuff from the camera, which no longer publicly exposes that information. Where are we going to put that? Okay, for the sake of like, temporary hacking, we'll remove this afterwards. I'm going to move the view projection matrix here. Get rid of it from there. And then I'm going to make it kind of publicly visible in here. And then we're going to output the start row, start column. Oh, wait, there's the dimensions of the image, right? Man, I've kind of like, I've created the perfect storm for myself for making this as difficult as possible to visualize. I might end up adding like a helper for like drawing 3D points and lines because that's going to be useful all the time. We also don't care about the depth. And what color are we going for? Let's go for yellow to blue. Why not? That's one I don't think we've seen yet. And That might work. I'm just going to bring in the color header. Oh, I've already got it. And let's run the build and see what happens. Oh yeah, I have to tell it which image I'm actually drawing to. That helps a lot as well. Okay, I've changed the header file, so I'm going to have to do a parallel build again. Come on, come on, you can do it. Okay. That's doing some weird stuff that doesn't quite look right. Oh, that side it is off the screen, so... Hang on, let me just bring up the scene in Blender and we can figure out roughly where we want the origin of this to be. Come on, Blender. Come on, Blender. There we go. Yeah, so we want it to be kind of focused on this point here, so I'm just going to grab this. Okay, I'm going to slow that down a bit and see if I can figure out what the heck is going on, because that doesn't look right. It doesn't look like it's quite grabbing onto the right points. Where am I incrementing that? There it is. Yeah, that doesn't look like it's doing the right thing at all. It is kind of grabbing onto points, sort of, but only sort of, I guess. Yeah, something's definitely going wrong there. Let's have a look at our... might not end up solving this today, but might be able to get a rough idea of what's going wrong. So, from top to bottom. Now we're pretty sure all of these positions and normals are right because we can see them and they look like they're pointing in the right direction to me. So we're getting vertex B. We're getting the difference between a point in 3D space and the corner, which should be working. From my dot product, which should get us the distance to the surface. That should be correct. We're then multiplying the surface normal. I've already done this once. Distance to surface. So we've actually just eliminated an unnecessary instruction there. And then we're getting multiplied normal out, and then we're then subtracting that multiplied normal from the constraint points. That should be getting us back down to the surface of the triangle. We're then getting the edge normal, and we're using that difference, which we've not overwritten. That's fine. It's still the difference between the point and vertex B. Multiplied by the edge normal. Yes, that's a multiplied normal. And then we're subtracting, hang on. That's wrong for a start. We're actually discarding the bit where it clamped it back down to the surface of the triangle. That could have been it on its own. Okay, that's looking a bit more rational. It still looks a bit weird. But it might actually be right, so I think it's actually just rising above the triangle. Yeah, that's still not quite right, but that's looking closer. Okay, we definitely had a bug there. Okay. So yeah, looks good. We're then getting the edge normal along BC, and then we're multiplying that by the difference again, which is fine because that's the distance to vertex B. Ah, I've just had a thought. And yes, it did hurt. Is this being broken by the fact that we are, you know, changing the points that we're sampling, that we're kind of like subtracting from? That one should be fine. That looks like it might be working. I'm going to temporarily just remove this bit here to like, prioritize ones that we're kind of above, because I think that's confusing the issue a bit. Yeah, that's definitely not quite right, but that's not looking a million miles off at this point. Oh, it's so frustratingly close. It's so close. Hmm. Ah. Yeah, I'm about to run out of time for today. And it's so annoying because we've got so close to getting that working. Oh, look at this. It looks like it's maybe it's constraining it more than it should to the... Oh, I've just realized what it is, and it's so dumb. Oh, okay, so what's happening here is that... Right. So this actually works if the point is outside the triangle, but if the point is inside the triangle, it's actually snapping it to the nearest wall. So I actually need to measure this distance here. And only actually snap it back if it is actually over that edge. So let's just do that quickly. And then we've got one more, which is the distance to CA. Okay, that looks again not quite right, but it looks extremely close. That looks way closer than it was. Actually, that said that. Oh, hang on, that's not quite working. Ah, but that is very, 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 very close. That's definitely closer than it was. Let's just double check what we've just done and make sure I haven't done anything immensely stupid, because that'd be on brand, wouldn't it? No, that kind of makes sense to me, what it's currently doing. It might be more obvious what this is doing if I could see it in kind of like 3D space, if I had kind of the camera moving or something. Let's, just for the sake of argument, let's just simplify this to a single triangle and then export it and see how that looks. Yeah, that's not right. It's crossed that edge and it's definitely not realized. So which edge is that? We can actually tell by having a look in the file here. So that's going to be edge CA by the looks of it, just by having a look at the data, because it's yeah. And I've taken point B, not C for some reason. Okay, that might fix it. No, that didn't fix it. Why not? Because I'm using the wrong edge normal. Last line effect every time, every time, every time. Okay. Let's build it again. Yeah, there we go. Now it's sticking to the edge of the triangle. That's good. So I just want to see it cross this line as well. I don't think it's going to cross that line. Okay, let's put all of our triangles back in and see how it looks. Now, some kind of weird snapping is kind of expected because of the kind of complexity of the scene. That looks like it might be kind of working. Maybe. It's kind of hard to be sure. Oh, that definitely wasn't right. Well, I'm probably going to have to call it there. So thank you very much for watching, and I hope you have a great Saturday. I'll be picking this back up tomorrow as usual.